Riley here in the classroom today, and we are going to talk about solving proportions. We're talking about ratios and unit rates and proportional relationships, all kinds of problems here dealing with these ratios that are equal to each other. And this next topic here, solving proportional relationships, very useful for lots of real-world problems, which you will see here shortly. All right, so we start on page 55. Katie and some friends are going to buy some fruit smoothies. Okay, you go to the health food store, and they're having a sale, 2 smoothies for $5. So fill in the boxes to write a ratio that compares the cost to the number of smoothies. Okay, so if they're going to buy 2 smoothies down here, 2 smoothies, that is going to cost them $5. Okay, pretty easy to fill those in. By the way, make sure you are following along in your workbook here as we go through this lesson. Every lesson where we use the workbook, you should be following along and filling in all the blanks. All right, so suppose they buy 6 fruit smoothies. So the number on the bottom now has changed to 6. Well, how much is that going to cost? Well, if 2 smoothies were $5, and 6 smoothies are going to be 3 times as much, or $15. Is the cost of the smoothies proportional to the number of smoothies for 2 and 6? Okay, is the cost proportional? Well, are these ratios equal? That's how we checked to see if relationships were proportional. Is the ratio, okay, if you divide these numbers, do you come out to the same answer? And the answer is yes. The answer is yes, because 5 divided by 2 is 2.5, and 15 divided by 6 is also 2.5. The ratios are equal. That means that the cost is proportional. And actually, this number, this 2.5, is the unit cost of the smoothies, right? Each one is $2.50 if 2 of them are $5. All right, so that's the introduction here. So we had this introduction to algebra things about talking about variables and variables right next to other numbers and how that shows multiplication. We're going to use all of that stuff today in this lesson on solving proportions. So that's why we did that prep work there. A proportion is an equation, okay? It is a mathematical equation that says that 2 ratios are equal. So a proportion is always 2 fractions with an equal sign in the middle. Okay, if it's all numbers, it looks like this. And if it's done with all letters, with algebra, it looks like this. Okay, A over B equals C over D can be any 4 numbers, as long as B and D are not 0. Okay, because you can't divide by 0 ever. So 0 can't be in the bottom. That's not a big deal. All right, so consider this proportion. A over B equals C over D. So now there's all letters here, no numbers. Okay. Well, they go through this work here to, if you multiply both of the sides of this equation by B times D. Okay. You multiply both sides of the equation by B times D. Then the B here on this side cancels out the B underneath here, because they would divide B1. And the D's cancel out here. And you're left with A times D equals B times C. Okay, notice that they don't write any multiplication symbols here. They just put the letters next to each other, which means multiplication. Okay, AD equals BC. These are called the cross products of the proportion. The cross products. And the reason they're called cross products is because they are the multiplication of the 2 numbers that are across from each other in the proportion. A times D and B times C, they're across from each other. So very commonly, you'll see people write these circles like this. Some people call this the butterfly method, because this looks kind of like a butterfly. Okay, you might see that somewhere. So by circling these 2 crosses, okay, the numbers that are across from each other in the proportion, you can use the cross products, and you'll see that if the proportion is true, that these cross products will come out to be equal, right? That 8 times 3 and 6 times 4 are equal. I don't like writing them like this. This is not particularly useful, in my opinion. So we're not going to do that. Okay, I will show you instead how we are going to use this cross product process to solve a proportion. All right. So they're starting here with a real world example, but then we'll go and do non-real world problems down here. All right. So the real world example says, after 2 hours, the temperature rose 7 degrees Fahrenheit. Okay. So write and solve a proportion to find how long it's going to take at this rate, it's heating up at the same rate, how long is it going to take to rise 13 degrees? Okay. So to set this up is you can set this up with a proportion. All right, and we'll talk a little more about setting these up. But when you set up a proportion, it is two ratios, okay? Two ratios that are equal to each other. Those ratios have to be the same things on the top and the bottom. Both sides of the ratio must be the same things on the top and the bottom. In this case, they're going to set it up as temperature divided by time, okay? So 7-degree rise over 2 hours. And on the other side, 13-degree rise over, I don't know how many hours, so we represent that unknown amount of time with a variable. We'll use the letter T for time, okay? So the key here is that this is set up as degrees Fahrenheit over hours on both sides of the equation, right? So degrees Fahrenheit over hours equals degrees Fahrenheit over hours. And what happens is 3 of these numbers you're always going to know, and one of them is the one you're going to try to find out. You're trying to solve for that unknown value, okay? So here's my proportion. 7 over 2 equals 13 divided by t. Sometimes these numbers are so easy you can just tell what the answer is. This one is not that case, okay, because we don't have good easy fractions here. So to solve this problem, we are going to use cross products. Okay, we're going to use this understanding that the multiplication across in a proportion, right? This 2 times 13 and this 7 times t are equal. That's what this says right here. Okay, so this is the next step you should be writing, is that the cross products are equal. 7 times t, and I write that with no multiplication sign in the middle, equals 2 times 13 is 26. Now, sometimes you'll write 2 times 13. Sometimes you can just write 26. It depends on how big the numbers are, okay? Kind of up to you for now, all right? So now this equation here, 7 times t equals 26. Now, last year you probably learned how to solve one-step equations. We will go over these again later on this year. We'll concentrate on solving equations algebraically. For right now, let's just recognize that in order to figure out what t is, I need to divide 26 by 7, right? So 7 times t is 26, then t has to be 26 divided by 7. Okay, they show you by doing it, dividing on both sides here by 7, which is the good algebra way to show this. Not so worried about that at this point in the year, but we will be worried about that later. Okay, so what you're going to do is in your calculator, you're going to do 26 divided by 7, and you're going to get an answer. A 3 point, I don't know what, 6, 7, blah, 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 blah. Could be anything. It could, and then you're rounding it off to something reasonable, okay? 1 decimal point is probably reasonable here, so that's 3.7 hours. 3.7 hours. That's how long it will take for the temperature to go up 13 degrees, all right? So that's an example that's done out for you. It's not that great, okay? It's kind of more difficult than it should be. Let's start by just solving just giving you the proportion and figuring out what it is, okay? So again, the steps in all of these problems is going to be to write that the cross products are equal, okay? So write cross products equal. And then you're going to divide to solve for the unknown. Okay, that's the steps. All right, so let's do these. We'll do this first, got it together, and then I'll let you work these other ones. All right, so solve each proportion. Okay, x divided by 4 equals 9 divided by 10. So our first step here is to get the cross products. So x times 10 and 9 times 4. Okay? So that's going to give us this, 10 times x and 4 times 9, which is 10x. I can write that as 10x. And then, sorry about that. And then 4 times 9 is 36. Okay, so now we're going to divide by 10 to get x by itself here. So 36 divided by 10. Let's write it like this by writing little divisions underneath. Okay, and 36 divided by 10 is 3.6. There's your answer. X equals 3.6. 3.6 divided by 4 equals 9 divided by 10. Next one. 2 over 34 equals 5 over y. Okay, we're going to set up the cross products. That's how we solve proportions. 2 times y, 34 times 5. That's 2y is equal to 170. Okay, so if 2 times y is 170, then y is going to be 170 divided by 2, or 85. Y equals 85, or letter B. Letter C. 7 divided by 3 equals n over 21. Now, this is one you might be able to get in your head, right, by identifying equivalent fractions. So sometimes the numbers are so easy that you could just come up with that answer. Okay, so 7 divided by 3 is equal to n over 21. Can anyone just figure out what n is, right, just by looking at these two fractions? Well, if this is 21 and this is 3, that means this is 7 times as much as this side, right? So this is really times 7. Whoops, times 7. Okay, so that means up here I'd have to do the same thing to get an equivalent fraction, times 7, which means that n equals 49. Okay, so that's kind of a shortcut. You can do that when the numbers are easy, right? You couldn't do that over here. 2 to 5, it's 2.5, right? 4 to 10. These are not easy numbers to use, but sometimes they're easy numbers. Okay. Now the fact is that no matter what the numbers are, using the cross product method like this will always work. Okay, so you can always use that method. Write the cross products. 3 times n equals 7 times 21. Use your calculator for these, all these things, okay? So 7 times 21 is 147. So 3 times n equals 147. And divide by 3, right? Divide by 3. Divide by this number in front of the variable to get your answer of n equals 49. All right, so that is solving proportions. That's solving proportions not in real world problems, okay? I'm going to stop there, and we'll look at real-world problem proportions in the next part of this video.